it is time for us to answer this question. Now, this is a follow-up question to that question. Now, if you are able to answer this question, I believe you've gotten 7 marks. It's a very simple question, but you need to understand the fundamentals that comes with it. Now, the question says, write the mechanism of reaction for E2 reaction. So this is an elimination reaction. And you know why we call it E2 reaction? Because you must be able at all time to identify the kind of reaction, because sometimes it may not be given to you. Now, whenever you have a strong base, like the one that have negative charges, all these one, they are strong bases. There is a very high tendency that it will be E2 reaction, even when the alkyl halide is a tertiary alkyl halide. All right, even when the alkyl halide is a tertiary alkyl halide, the possibility that it will be E2 reaction is very, very high. Now, this thing here is supposed to be bromine, not what we have here. So we are supposed to have one bromine here. So let me put here as B arrow. This is a mistake from my own end. So yeah, it's supposed to be B arrow, or any one of these ones should be the B arrow, but I think this one is the B arrow. Now, how do we write the mechanism of reaction for this? So firstly, I'm going to take them here and then show you how to do that. The reaction say H3C, they will have O negative, plus then we have CH3, we have C, here is CH3, and then here we have CH3, and then here we have BR. And we are asked to write the mechanism of reaction for this reaction. Now for E2 reactions, what did we say? We said that for every E2 reaction, this base here, because what you have here is a base, B negative. This base here with negative charge, we attack or we abstract a proton from here. So one thing we are to do here is to write CH2 and then write the hydrogen here in such a way that this one here, we abstract this hydrogen from here. You know, here was CH3, right? But now I actually brought it out here so that we can actually remove this hydrogen from here. Good. So if we do that, if we remove hydrogen from here, it means we are now having a bond. This bond here will actually kick in here. E2 mechanism is a constructed mechanism. It will kick in here, and as it's kicking in here, this B arrow will leave, and this will form a transition state that you should always write. So the transition state here will be something like this. We are going to have a situation where you have the what is it called? This group here, H3C, which is the nucleophile, right? Weakly abstracting the hydrogen. It has not fully abstracted it. Are you getting it now? And also, this bond here, which is the bond of the hydrogen, has not fully formed. And also, another thing that you also take note of is we have this CH2 here. We have a bond here before. Now, this new bond that is coming here is not fully formed. So we are going to represent it with dotted line. And then you have this C. And then, of course, you have CH3. And then, of course, here, you have CH3. And then this bromine that is leaving has not fully left. So you are going to have B arrow. And you are going to have something like this. And then the charge here, you have something like double dagger to tell you that this is a very high energy state. This is what the transition state is all about. Is that okay? Look at it. This one is a constructed mechanism for E2 reaction. It occurs in a single step. Firstly, the nucleophile will abstract hydrogen. When it's abstracting hydrogen, according to what we say, hydrogen is H+. The bond is not being taken with it. So this bond will pack in here so that we are going to form a double bond here. But this double bond is not fully formed. This hydrogen has not fully been abstracted or has not fully left at the transition state. And as a matter of fact, if you count the amount of bond, if there's a bond, if you count the amount of bond around carbon, it becomes 1, 2, 3, 4, 5. It can't be. So this bromine, which is a more labile group, will leave. Now, at the transition state, this bromine has not fully left also. So at the transition state, just like a transition, we are passing through a phase. It means you never live your old life and you are not also in a new life. yet. You are just in the middle, in between. That is why we have all the dotted lines to actually represent them like this. And then after the transition state, you are going to form the final product where these two has reacted together, and then this CH2 here, this bond has broken. Are you getting it? At this part now, this bond don't break, so it has formed a full bond. This B arrow also has broken. B arrow is no longer here. So what you are going to form is CH2 double bond C. Here will be what? CH3. Here will be what? CH3 plus. Now recall that when this H3C and OH come together, it's going to form CH3OH plus the bromine that left, which is B arrow negative, because it's having 8 pairs of electrons, which is 4 pairs of electrons, which is 8 lone electrons rather. All right, so this is the final product of this reaction. Is that okay? So this is the reaction mechanism. Now, what is the name of this product? This is 1, or we can say 1, 2, or we can say 1, 2, whichever way you want to call it. You say this is 2-methyl propene, or we can say prop 1-ene, or 2-methyl propene. This is methanol that is formed here, and this is the bromide ion. And of course, what reacted here was initially are we going to call it 2-bromo-2-methyl propane. That is what was here, 2-bromo. If you write it out, 2-methyl propane. All right, so that is the mechanism of reaction for this particular reaction. Now the next one is, what is the order of the reaction? Now if you look at this reaction very well, it's E2 reaction, so the order is a second order reaction. So we can say order is second order reaction. Write the rate equation. Now what is the rate for a second order reaction? Rate is K times, we have this as the substrate. I told you that here what you have here is B arrow, right? So this gives us H3. We have let me put it like this. We can write it as CH3 into 3 place, which is 1, 2, 3, and then you have this C B arrow as your substrate, and then you have your HC and O negative, right, which I can write as CH3O negative. So this is the rate equation for this reaction, right? Now the next thing is draw the reaction energy diagram, or draw the energy diagram for this reaction. So what you are going to do is to take these ones very serious, because as I go to the next slide, this is going to wipe off. So the next part says draw the reaction diagram, energy diagram. Now energy diagram, we say it usually goes from here, and then it goes like this too. And then we said we have, for E2 reaction, it's just one phase, one transition step, which we go this way, and then it comes this way. And then of course, what is in the reactant, this part here is the reactant. So what are those things in the reactant? You have CH. What are those things in the reactant? We have CH3, then CB arrow, plus we have CH3O negative. These are the two reactants that we are given. And then of course you are going to write the transition step. The transition step is what will be formed here. Almost everything that we wrote in that transition step, that will be what will be formed on top of here. And what are those things that were in the transition step for that reaction that we wrote? We had CH3. Let me just pray that this space is enough. O negative, partially bonded to hydrogen, and this hydrogen was bonded to CH2, because we have a partial bond here, 2, which is CH2, and then we had something like this, partial bond here, then we have C, then we have CH3, CH3, and then a partial bond to what? Bromine. And of course, we went further by saying that you have something like double dagger here, right? This is a transition step for this reaction, and you must state it, high energy state, transition step. So this part of the reaction is called the energy, the label, and here is the reaction coordinate. All right. And then finally, the next thing we are going to do now is the product. What was the product of this reaction? We have CH2 double bond C, and then you have CH3 plus CH2OH plus B arrow, like this, and this is the product of the reaction. So this is what you are expected to write or to draw for the transition step for this particular reaction. It's quite easy, right? Exactly. So that is that for this particular question. I think there is no other question here. So if you've done this, you've gotten 7 marks. Perfect. Thank you. We'll see you in the next one.